Welcome back to another video, and in this video we're going to be continuing on with our macOS development with AppKit tutorial series. And in this particular tutorial we are going to be taking a look at how we can send GET network requests to a server in AppKit. Now, generally speaking, the process of sending a network request is the same across all Apple technologies. We will be using what's called URL session, and we will be using async await syntax. Now, what is URL session? Well, URL session is a class that allows us to send, for example, GET requests. It allows us to send POST requests, put and patch requests, as well as delete requests. It allows us to download things from the internet, all kinds of stuff that have to do with networking. URL session is capable of. And what is async await syntax? Well, you may have heard about async await syntax off and on from other places, but basically async await is part of a larger feature set in Swift called Swift concurrency. And pretty much this allows us to more easily manage concurrent code without having to use Grand Central Dispatch or GCD like we had to previously. So you can say, hey, I want to do this on another thread. You can use async await for that. Now, Swift concurrency goes a lot deeper than just async await. If you want me to kind of walk through some of that stuff, let me know. But for now, we're going to not take a look at all the more advanced stuff with Swift concurrency. We're going to only take a look. We're going to be using only a handful of things from Swift concurrency to allow this to work properly. All right, so let's go ahead and start by talking about how we prep our models for a network request. First, we have to make sure that our model and our response, our API response, matches exactly, case for case, letter for letter, in terms of the properties inside of your class and the keys inside of any objects in the response. So I'm going to open up Terminal. And I'm going to say curl http://localhost /API/projects. And you can see here we have an ID, a name, and a project status, as well as bugs. Well, inside of Xcode, this is my project model. This class conforms to identifiable and inherits from NSObject, which means it also inherently conforms to hashable. We have a variable called ID, and this is a UUID because the string we get back from the server is a UUID, and the JSON decoder that we're going to use will detect that. Then we have name, which is a string, and we have is closed, which is a Boolean. perfectly matching our network response. And then we also have bugs, which is an array of bug report objects, which again matches our response. Now, bug report is another model that we have, and it follows the same conventions that we're following here. Now, the other thing about data models when working with network requests is that each model must conform to one of three things. Either A, it must conform to codable, which is a type alias for decodable and encodable protocol conformances. B, decodable, which is the protocol in Foundation used for decoding from JSON to Swift objects. Or encodable, which is pretty much the exact opposite of decodable. It encodes Swift objects to, for example, JSON, which allows us to then send that JSON in a request to the server. So inside of our project model here, let's conform to codable, because I want to be able to decode and encode data. We can save that. Same thing goes for bug report. So I'm going to jump to the definition of bug report. And we can add the codable conformance like that. And there's no required like properties or methods or anything like that that we need to implement. Unless you want to do some kind of custom parsing logic, which I don't, so we don't have to worry about that too much. We can save this. And save that. Now, the next thing that we want to do is we want to create a network manager. Now, this is going to be a class that will only allow us to have one instance throughout the entire lifetime of our app, because you don't want multiple network managers running around your app. It's not great. It's not efficient. And so to do that, we're going to utilize a design pattern called singletons. Now, singletons are exactly what I just said here. They are single instances of classes, and you cannot create more than one instance of said class. You see these very often when developing iOS and macOS apps. For example, URL session, user defaults, file manager, all of that stuff, all those things are singletons, because you only want one instance, ideally, of those things. So let's go ahead, go into our navigator, go into our project navigator. I'm going to we're going to create a new folder, and inside of this new folder, this new folder is going to be called services. And inside of this services folder, no computer. I want to say new file from template. We'll say Swift file, and I'm going to call it Network Manager. And inside of Network Manager, we will import foundation, and then we'll say class Network Manager. Now, here's what we need to do to create our singleton, the single instance of our Network Manager. We can say static let shared equals Network Manager. The second step is to create a private initializer. That way, you can't create another instance of this object anywhere else. So private init. And make that an empty initializer body. And there we go. Now we have a network manager that is a singleton. The next thing that we need to do is we need to create a method to retrieve all projects from the server. And to do this, we're going to say func get projects, and then we're going to make sure that we have the opening and closing parentheses there. Then, to make sure that this method can be executed asynchronously using async await syntax, we're going to mark this method as async after our parentheses. Second, we want to make sure that this method can throw any errors that come up, because when you're sending and retrieving network requests and responses, things can go wrong. So go ahead and mark this as throws. Now, async and throws has to be in this order. Async comes first, then throws. Otherwise, Xcode will pitch a fit. So make sure you don't flip-flop those around. And then, finally, we want to tell the method what it should return. And this method should return an array of project objects. So we want to return an array of projects. Open up the body of the method, and there we go. We have the skeleton of our method created. Now we get into the bread and butter of what we're learning today, and that is how to send that network request. So the first thing that we need when sending a network request is we need the actual URL that we want to send a request to. And we can do this using a URL object, but the initializer that we need to use is optional. And it's optional because you could enter an invalid URL into its initializer, and at that point it wouldn't work, right? So we need to use a guard statement to unwrap that the results of that initializer. To do that, we can say guard let URL equals URL, and we want the initializer that takes in a string. And this string is going to be the URL that we want to request something from. So http:// localhost 8080/API/projects in my case. This might be the YouTube. This might be a YouTube API. It might be a Google Books API. It might be the iTunes Search API. It might be the GitHub API. Any kind of RESTful API that has a URL endpoint and that you want to use, put it there. All right, next, what do we want to happen? What do we want to happen if this doesn't succeed? Well, we will say else return nil. Now, I'm going to change this to an optional array of projects because maybe, just maybe, we return nil here, so we could have nothing that we want to return. Next, we need to actually send the request. And when we do that, we'll get two different returns, two different values. We'll get the data that the server responds with, and then we'll get the response object, which contains things like the status code, any headers, stuff like that, from the request itself. We only want the data in this case, so we can do that by saying let data, underscore. So we're using destructuring here to retrieve individual values from a tuple equals URL session dot shared dot data from URL. Now, inside of Xcode, after we do this, we will get an error, and it's basically telling us that these errors are pretty much going to tell us that our call to the data method is both asynchronous and the method can throw. So we have to mark this with both try and await. And so your initial thought might be to say await try. So await try URL session dot share dot data from URL, but you would be wrong. If you look in Xcode now, we get an error saying, hey, try must precede await. So you must put await before try. Like that. So try await URL session.share.data from URL. And the reason why they chose to do it this way is because simply it reads better. You're trying to await something. You're not awaiting and trying something. So that's kind of why they do it that way. Now that we get the data from the server, it's now time to actually decode that response. And to do that, we need a JSON decoder. So we'll say let decoder equals JSON decoder. Then we'll say let projects equals decoder.decode an array of project dot self. Now this parameter here, array of project dot self, is the type of data that we expect to decode from the JSON. So if we take a look in our terminal again, you can see that the response is an array of objects, and these objects are of course projects. So therefore, we are decoding an array of project objects. And then the second parameter it expects is some data. So we'll give it our data from when we retrieved a response from the server. And so finally, we can return projects like that. Now, we want to mark the call to decode from our decoder with try, because things can go wrong when trying to decode some JSON. Maybe there is a mismatched key and property pair, and you want to be able to catch that. So we have to mark that as try. And there we go. Now that our networking code is done, we can move on to our view controller. Now, if this was before async await existed, the code would look a lot more messy, a lot more confusing, because previously we would have to use GCD and closure-based syntax, and it just looked yucky. It wasn't fun in the slightest to work with. But async await makes things look so much better, and it makes things so much easier. All right, so now let's go to our view controller. I'm going to do this inside of viewDidLoad after we configure the UI. You can do this, you can kind of experiment on where you want to put this. There are certain places where you don't want to put it. For example, you don't want to put this in an initializer. Something like a viewDidLoad or a viewDidAppear or something like that might work better, but definitely not in an initializer. All right, so inside of viewDidLoad, we need an asynchronous context to mark our call to get projects with await, because right now we are not in an asynchronous context. viewDidLoad is a synchronous context. It doesn't do anything asynchronously. So we have to enclose this in what's called a task. Now, if you look in the inline documentation, it is basically just a unit of asynchronous work. That's all it is. And if you wanted to, you could specify a priority and all that stuff, but that goes a little bit deeper into the weeds than we need to go. So inside of this task, we now have a context that's asynchronous. So we can say projects equals await And we can say network manager dot shared dot get projects. Now you will get an error saying, hey, this method can throws. You got to mark it with try. So I'm going to surround this with a do block. And then we'll have a catch block where we will print error print error dot localized description. And then we want try await network manager dot shared dot get projects. All right, so here we can say if let projects equals try await network manager dot shared dot get projects. If that's the case, then we can say projects, so self dot projects equals projects, like that. Go ahead and save the code, and let's run it. Now, when we run our code, we can see an NS table view displayed. It takes up the entire window. There are two columns, the name and the status of the project. And inside of the table, if your network request works properly, we should see rows in the table. However, we do not. Now, why is that? Well, we don't see anything because I did not apply a snapshot to the data source. So I'm using I'm using an NS table view diffable data source here, hence why I need to apply a snapshot. Let's run our code again. And here we are. You can see now inside of the table, we have a single row populating our table, which is precisely the result we expected, because there's only one project currently in the database of my API. Now, if you don't want to deal with any concern about updating your user interface on the main, always making sure that you update it on the main thread, what you could do is surround apply snapshot with let's go ahead and say dispatch queue dot main dot async and then in here we'll say self dot apply snapshot. So that way we make sure our UI updates happen on the main thread. This is using Grand Central Dispatch. So you can mix and match async await and Grand Central Dispatch, but you do have to be a little bit careful with it because concurrency is it's a tricky game. Let's go ahead and save this and run our code again. And you can see we get the same result. So that pretty much does it for this video on how we can send GET requests to an API on a server somewhere using AppKit and displaying that data in our user interface. Thank you all so very much for watching, and we'll see you in the next video.